All right, let's jump into the material. I don't know if it was just my own tiredness last time or if I was actually reading you guys right, but I got the feeling when we started metaphysics, I was kind of losing you. So we're going to restart metaphysics. Maybe finishing the organon was just a bit exhausting. So restart metaphysics, fresh start from the top with metaphysics. Now starting out with metaphysics, number one, remember for Aristotle, the laws of logic, which are the law of contradiction, the law of excluded middle, and the law of identity, these are metaphysical laws. So here's our physical universe. Our physical universe is governed by physical laws. So in here we might have like Newton's law of gravity. That is something that every physical object in our universe is subject to. When we look beyond just our physical universe and we look at existence as a whole, this is where the laws of logic apply. They are more foundational than physical laws. Not only is every physical thing in our universe bound by the law of contradiction, but even our formulation for Newton's law of gravity is bound by the law of contradiction. In other words, if I'm trying to formulate some law that governs our universe, and it leads to a contradiction, in other words, it violates the law of contradiction, that's already a good enough reason for me to get rid of my law. If my law leads to contradiction, I can be sure my law's out. It doesn't work.
What's the law of contradiction?
A law of contradiction says something cannot be both true and false with the same respect at the same time. So you can't have both A is the case and not A is the case. That's impossible. It has to be one or the other. So that's an example of one of our laws of logic. This is a metaphysical law. It governs more than just our physical universe. It does govern our physical universe, but it governs everything. Every concept that you can have is bound by the law of contradiction. So here's our physical universe, and it's bound by physical laws. But then there's everything in existence, going beyond just physical things. For example, Newton's actual law of gravity. That's not some physical thing, you can't go touch it. And yet it too is bound by the laws of logic. So they're metaphysical laws that govern over everything. You can't get away from them. Now, what has primacy in this system? We've talked a lot about this square that we had. And every concept, every notion, every idea falls into one of these two categories. We had predicated and not predicated. This is just either it's a universal or it's not a universal. Right? And then we had in, and then we had not in. That's my symbol for not. Line dash down. And in means it had to be in something to exist. So let's get examples for each of these to help us get comfortable with all. First off, something that's not a universal and doesn't have to be in anything to exist. What are these things?
Your primary substances.
These are our individual, particular things that you see around you. This piece of chalk, that thermos, that camera, that block, this block. Every individual, particular thing you can see around you, including me. I'm a good example. Individual, particular entities. Those are things that are not universals, they're particulars, and they don't have to be in something to exist. They just exist. Now, let's look at things that are universals, but don't have to be in anything to exist. These are collections of these things. So over here you see me, over here this exact chair, that's right here. So you have me and all the individual men, and you have chair and all the individual chairs. Over here you have the universal men and the universal chair, or chairness, whatever you want to call it. What Plato was talking about with his forms are right here. These are Plato's forms. Okay, and then we had predicated and in. These are things that are universals and have to be in something to exist. What's an example of those?
Red.
Red is a good example. These are pretty much all your adjectives. I can say, look, there's a man. I can't say, look, there's a red. You say, a red what? It has to be in something for it to exist. I can't have red here. I can have men here. Men don't have to be in something to exist. Men are men. But I can't get red here. I can't get running here. Say, look, there's a running. A running what? So these are all your adjectives that you pretty much apply to objects. And then finally, the last category, probably the weirdest one, things that are particulars, but have to be in something to exist. What's an example of that? Your particular memory of last week. Your particular memory of last night. We're not talking about the abstraction memory being capable, possessing a memory. We're talking about your individual memory that you had of yesterday. That's a good example. Or your particular knowledge of some subject material. If I get rid of you, I got rid of your memory. But I can't take that memory and get to exist independent of you. There's you, here's your memory. No, it has to be in you. Now, Aristotle's big point is that everything ultimately depends upon this category for its existence. Red only exists if it exists in something. Your memory only exists if it exists in you. Furthermore, men or chair, those are just collections of these things. So if you get rid of this box, you get rid of your whole universe. So he puts primacy on these substances, and that's why we call them primary substances. That's where they get their name from. Now remember, he's completely opposed to Plato here. Remember, Plato's whole view was that out there somewhere, don't ask me where, there's this world of forms where chairness exists. There it is. And then through some sort of projection, it projects into our universe and it produces a lot of chairs. And so the chairness is what's real, not the chairs. Up there in the world of form, there's redness, and it casts its shadow, and its projection creates a lot of red things. And so red is what's real, not the red objects. Chairness is what's real, not the chairs. Aristotle says, no. The chairs are for sure real. Everything else is dependent upon the chair for its existence. Chairness doesn't exist out there in some different dimension. Chairness exists in the chairs. Redness doesn't exist in some different dimension. Redness exists in the red objects. That's where redness exists, right there in the particular. So he puts the primacy on these primary substances. So note that primary substances are prior to everything else. Everything else is dependent upon them for their existence. That's what we mean then. Not only is an individual particular its own thing, but it's a type of thing. It's a particular of a universal. So now we're going to do an analysis of these things and talk about what we can know of these things. Here's our primary substances. Here's what we're interested in. What can we know about these primary instances? So fundamentally, every primary substance, every individual is composed of matter and form. The matter is what makes it this thing as opposed to that thing. It's what we call the individuating element. And the form dictates what type of thing it is. We call that the universalizing element. So here I grab two markers. The form that these have is they're both markers. A form that they both have is they're both capped objects. A form that they have is they're both plastic objects. This has a form of being blue, this has a form of being red. In that sense, they're not the same. But are these two actually the exact same object? No. For Aristotle, why are they different? How are they different? He says they have different matter. In a lot of respects, they have the same form, but since they're composed of different matter, they have to be actually different things. Now, what if they had identical forms? So even if you took a more modern view of an electron, with our modern theory, two electrons are completely identical. One electron is no more electron than another. They're completely identical in every respect. And yet, they're not the same electron. One is different from the other. Why are they different, according to Aristotle? Because they're composed of different matter. So every individual thing you can go grab out there, whatever it is, first off, it's an individual thing because it has its own matter, but it's a thing of a type. I could ask you what this is, and you could tell me it's chalk. That's universal. Many things are chalk. So the matter is what makes it this thing as opposed to other things. The form is what it has in common with other things. Make sense? Form and matter, two very important words in Aristotle's Metaphysics. Now, he's not just talking about actual physical things in our universe. This goes beyond that. It goes into everything that exists. So even to arguments. So I'll give you two examples of two arguments. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. All cows are animals. Betsy is a cow. Therefore, Betsy is an animal. Those two arguments have the exact same form, but they have different matter. They have different substance. Same form, different substance. If we were to look them up on, remember that table that Aristotle made of all the different possible arguments you can have? They both fall at the same point on the table. So same form, same logical structure, different arguments because they have different matter. Well, there's 2,000 steps. Okay. Now, matter and form for Aristotle are relative terms, kind of like species and genus. So something may be matter relative to one thing and form relative to another thing. So let's take you through a chain of these to help it make sense. So let's think about a house composed of bricks. So what's the matter? It's the bricks, and the form that they have is a house. House is a form composed of its matter, bricks. Furthermore, I could go take one of those bricks. Well, that brick is composed of concrete. Relative to the brick, its matter is concrete. Relative to the concrete, the form that it's in is a brick. And I can go take a little bit of that concrete. Well, that concrete is composed of atoms, we could say. So the atoms are matter relative to the concrete, and the concrete is form relative to those atoms. And I can break down the atom, and I can say an atom is composed of protons, neutrons, and electrons. So protons, neutrons, and electrons, those are matter relative to an atom, and an atom is form relative to protons, neutrons, and electrons. It's a particular form, you can put those things in. Furthermore, we can take those protons and neutrons, and those are composed of quarks. So quarks are matter relative to protons and neutrons are form relative to quarks. And we can keep going back, all the way to what? How far back can we go? Is there some starting point from which we kick all this off? Is there something out there that's just pure matter? Some formless matter doesn't exist? Some pure matter with absolutely no form? Well, Aristotle's going to argue no here in a second. He thinks everything is ultimately backed up by what he calls prime matter, but that prime matter can't actually exist anywhere in the universe. We'll try and make that make sense. Unless you have any questions so far. While I take a sip.
So everything, all of the not predicate, not in, is both a form and a matter. Exactly.
Everything that falls into this category is a particular matter with a particular form.
Gotcha.
The matter is what makes it this thing as opposed to that thing. How do I know for sure that me and you are different? We have different matter. That's how I know for sure we can't be the same thing. However, we can have similar forms, or we may have drastically different forms. So a form is what makes something intelligible. If you were to tell anyone something about me or someone anything about this, it would always be expressed in terms of its form. You'd be telling them universals about it. It's white, it's chalk. You might tell them it's smooth. Whatever those are universals that could apply to many objects. You can't ever just communicate, it's this matter right here. Because again, you're just communicating a form that it has of a particular position that's in. Anyways, so for Aristotle, matter is anything we can impose structure on. And form is any type of structure we can impose on something, or any type of universal. Universals are just structures that we put on something. Structure, universals, same thing. Okay. So everything is a particular of a certain kind. Or in other words, everything is an instance of a certain universal. Or in other words, everything is matter of a certain form. I just said the same thing 3 times, trying to get you comfortable with this Aristotelian language. A particular instance has its own matter. A certain kind is a universal that captures a certain form. Make sense? Relating those 3 words together. Well, 6. Those 3 and then those 3 again. Okay, so now we're ready to tackle Heraclitus and Parmenides. Remember, you've always got to deal with these 2 if you're going to put up some theory for how this universe changes. Make sure you address them. So going all the way back to Heraclitus. What does Heraclitus say? Heraclitus says change implies a contradiction. At the end of the change, it both is and is not the same thing. It is the same thing because we didn't replace the object, and it isn't the same thing because it changed. Let me give you a sense for what he's saying. So Heraclitus, I've got this chalk. Watch real closely. I'm going to turn it into an eraser. Ta-da! You say, no, 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 you cheated, you replaced it. So when we talk about something changing, that means you can't replace it. That's cheating. So when something changes, it is the same thing, since it changed and wasn't replaced. Now it's also not the same thing. Watch me change this chalk. Want to see it again? You're saying you didn't change it. To change it means you actually have to change it, so that it's not the same as it was. So when we say something changed, we mean it is the same thing as it was, because you can't replace it, that's cheating. But it also is not the same thing as it was, because something has to change. This was going all the way back, Heraclitus' confusion with change. And so, Heraclitus thought change implies contradictions. Once you get the contradictions, you can't have any entities. And so here we are in a Heraclitean world, everything's always changing, and we can't know anything about it. Tough. So what does Aristotle say to Heraclitus? Aristotle agrees that after change, something both is and is not the same thing. He's going to agree with Heraclitus, but in two different respects, so that there's going to be no contradiction. So when an object changes, Aristotle says its form changes, but its matter stays the same. So he's saying after the change, you have the same matter that you started with. So you're right, Heraclitus, it is the same thing. But the form changed. So you're right, Heraclitus, it's not the same thing. It's different in terms of its form, but it's the same in terms of its matter. And now there's no contradiction. The form changed, the matter stayed the same. No contradiction. We're not saying the form both changed and didn't change, and we're not saying the matter both changed and didn't change. We're saying same matter, different form. That's what change is. So when an object changes, its form changes, but its matter stays the same. I wrote typically because you have to get down to some fundamental matter. You can always find a low enough level of matter where it all stays the same. So I'll give you some simple examples and get a little bit more complex as we go. A ball moving. I got a ball here, I throw it over here. What's the matter for the change? The ball. What's the change? It went from being in this position, object with that form, to being in this position, an object with that form. So same ball, same matter, different form. Being here to being there. Slightly more complex. Building a wooden chair. In the beginning I have a pile of wood, at the end I have a chair. The matter is the wood. All the wood that was in that pile is still in the chair. So we have the same matter both before and after. It's the form that changed. That wood took on the form of being in the pile to being in the shape of a chair. Same form, different matter. Now, if we looked at some caterpillar turning into a butterfly, that's a bit more complex. What would be the matter for that change? It would be fundamentally the organic material that ultimately everything was composed of. And we could go, ultimately, if we want to go all the way down to the level of atoms, we could go check all the atoms that made up the caterpillar beforehand, and we could go check down all the atoms afterwards, and okay, everything's accounted for. No matter poofed out of existence, all the matter that was there before is there after. And it's just went from being in one form to being in another form. So no contradiction.
Does he define change if you actually remove matter from the form?
He would say you need to account for everything that went into the change. So maybe eating a leaf was part of it. Or maybe you need to keep track of the cocoon and the butterfly. Or whatever.
Or like the gas that leaves while it did not like that.
You can track it down to whatever detail you want, yes. He would say if you track down everything, ultimately it's all accounted for. So just a matter of how much tracking you want to do. So for Aristotle, I'll give you a couple different ways that he defines change. Here's one way. Change is the process by which matter takes on a new form. That's change. Note that with this definition, there is no contradiction inherent in change. So we've dealt with Heraclitus. Okay, now we got to deal with Parmenides. What's Parmenides say? Parmenides says there's no such thing as change, because in change you have what is becoming what is not, and what is not becoming what is. He thinks you have something going out of existence and something coming into existence. You can't have things going out of existence and coming into existence. Because then you have being becoming not being, and not being becoming being, which for him is this contradiction. So, to this, Aristotle says no. With change, the matter, the most basic matter, if you were to get all the way down to it, always existed. We never actually have anything going out of existence, and we never actually have anything new coming into existence. All the matter that exists in the universe is all the matter that exists in the universe. There's no pooping into existence, there's no pooping out of existence. Everything that there is, or always was, and always will be. All the matter. It's just changed from being matter of one form to matter of another form. Nothing new really came into or went out of existence. So sorry, Parmenides, you're wrong. Any questions with how he deals with Parmenides and Heraclitus? All right. So for Aristotle, our world is both a changing world. Remember, Parmenides thought there was no such thing as change. Aristotle says, no, we don't with Parmenides. It's a changing world. And it's also an intelligible world. It's one that we can understand. So Heraclitus is also wrong. We can understand everything. The world is as it seems for the most part, and it can be understood in a manner compatible with the way it seems. Now, why do I put for the most part here? Well, because we might come to bad conclusions. It's not that the world isn't the way that seems, it's just you might jump the gun on things that are unintuitive. Common example that the sophist would bring up, you take a stick, you stick it in water, it suddenly looks bent. And the sophist says, oh, you thought this was bent, but look, it wasn't really bent, your senses deceived you. Aristotle says, your senses did not deceive you at all, you came to a bad conclusion, but your senses told you exactly how it was, which is that light gets bent as it travels through the medium of water, which causes it to look like that stick was bent, because the light was actually bent. And if you understood everything involved, you'd understand that the world is exactly the way it seems. If you know all the facts about it, it perfectly explains the way the world seems to us. The fact is a fact. You never get a call, a fact just an illusion, and throw it out. The world is the way it seems. You might accidentally misunderstand it, but it doesn't change the fact that the world is the way it seems. It has to conform with the facts. So, not only does change not contradict the laws of logic, but change presupposes the law of logic. Here's a standard Aristotelian way of doing things. You're wrong, and even if you're wrong, and even if you're right, you have to accept I'm right. So, he says, there's no contradiction in change, and furthermore, if you accept change, you have to accept the laws of logic. So you can't use change to argue against the laws of logic. Now, how's he going to say that? Let's think for a second. We're going to do away with the law of contradiction and think about change. I've got some object, some chair, and in the beginning it's not red. And it goes through a change of becoming red. But of course, without the law of contradiction, red and not red are one and the same thing. And so it's not red. And so it went from not being red to not being red. No change occurred. If you want to claim a change occurred, you have to use the law of contradiction. Make sense? You say that there's a change. I say, prove it to me. You say, here's the chair, it's not red, correct? I say, yes. You paint it. You say, now it's red. I say, correct. You say, therefore change happened. I say, how do you know that red's not the same thing as not red? You say, well, the law of contradiction, that's how. Because it can't be both red and not red.
Gotcha.
So you have to use the law of contradiction to argue for change. Furthermore, if we ignore the law of identity, we can just substitute and call it change. So, according to your concept of change, I did not just change that piece of chalk into a marker, or into an eraser. Because I substituted it. You said that's cheating. That's not change. What do you mean that's cheating? You say, well, because this is what it is, and it's not that. And so you make a reference to its identity. A thing is what it is. And so there has to be that thing for change to even make sense. So even in the notion of change, you have to presuppose these laws. So you can't try and use change to argue against the laws. That makes sense? Okay. So, introducing two more important words for his benefit. So the first two were matter and form. The next two are going to be actuality and potentiality. It's probably worth noting as a historical note, these words that we use get their genesis in Aristotle. And so we pretty much use these words the way that he used them. You might say, wait a second, didn't Plato talk about the theory of the forms? Well, actually, he talked about the theory of the ideas. And we now call it the theory of the forms because it turns out what he was trying to talk about is what Aristotle later introduced. And Aristotle called it the forms because he knew what Plato was getting at. So, we largely use these words already the way that Aristotle intended because that's where they get their words in, Aristotle. So, potentiality and actuality. So, a particular has matter, and it has an actual form. It's actually in a particular form. This actually right now is chalk. A stick of chalk. That's what actually is right now. It is possible to change the form of the matter into another form. It's possible for me to ground up this stick of chalk. I'm not sure what I said before. This stick of chalk into some pile of dust. So this is potentially a pile of dust, but it isn't actually a pile of dust. Right now, it's actually a stick of chalk. And it's potentially a pile of dust. So, a particular has matter and an actual form. It is possible to change the form the matter is. It's possible to change the form of the matter into another form. The different forms that matter could take are its potential. So what is potential? It's the forms that this thing could take on, not the form that's actually in. The form the matter currently has is what it is actually. Make sense so far? Okay. Examples. An acorn is a combination of form and matter. Got an acorn. It's got its matter, its individual matter, and it's got the form that's in, which makes it an acorn. And based on its form, we know that it is potentially an oak. If I got that acorn, it's possible that I could go plant it in the ground and grow an oak. So that acorn is potentially an oak, but it's also potentially just decomposed organic material. I can also just go drop it in the gutter and it will slowly decompose. So that's what potentially is. It is not actually an oak until it takes on the form of an oak. Then it's actually an oak. Till then, it's only potentially an oak. It's one of the things it's matter for. An object's actuality dictates its potentiality. What an object actually is dictates what it potentially could be. In other words, this can only potentially be certain things. This cannot potentially be a planet. Not enough matter there. This cannot potentially be a star. This could potentially be a pile of dust. If I have a pile of wood, it is potentially a table. If I have some liquid water in a wheelbarrow, it is not potentially a table. I cannot build a table out of water in its liquid form.
This is very confusing, especially when you brought up the concept of like acorn to an oak tree. Like an oak tree is like what if you were to like determine how much of the matter from the acorn is now in the oak tree, it's probably 0.00001%.
Well, you're thinking about the full-grown oak tree, but now go back to when it first just sprouts. And then that's pretty much all just right there in the seed. But you're overthinking it.
Well, maybe
When that oak comes into existence, it pretty much came from the acorn. But the point is that you cannot go get an acorn and have a maple come out of the ground. That never happens. So it's what, because remember, we're laying a foundation for science. He's going to be talking about, I plant apple seeds, apple trees come up. And only apple trees ever come up if anything comes up. Maybe the seed doesn't take and it dies off and it becomes something else. But there's a reason that an apple seed becomes an apple tree. It's because that's what it has the potential to be. It never had the potentiality to be a peach tree.
I'm probably overthinking it. It just, the logic here is difficult to really get down because if we launch that piece of chalk at the sun, eventually it's going to be part of the sun.
It's going to be part of the sun, but this itself can't become the sun.
Yeah, and it's just, but when we're looking at it's hard to know if you take too much of the matter away from something, when does it stop becoming that thing? And it's like, is the barrier that whatever.
So if you want, you can say that oak tree with this environment, or that acorn with this environment is potentially an oak. Sure. That apple seed with the same environment is not potentially an apple tree. Or, I think I said that wrong.
Yeah,
that acorn with the same environment is not potentially an apple tree. You're not going to plant an acorn and get an apple tree. It's never going to happen. It's never going to happen that you plant an acorn and get an apple tree. If it was genetically altered, you changed what it was matter. You changed the matter of it, and you changed its potentiality.
Okay.
One way to think about it, the potentiality, more modern people when they're talking about Aristotle, is he's saying relative to living things, he's talking about the genetic code of the thing. And the genetic code of the thing is instructions to produce one type of thing and not another type of thing. And it's right there in the matter, right there, the genetic material, that would be part of the matter of a thing according to Aristotle.
just seems like if you were to really define this, it would have, you basically just have to say whatever the form it is after the change, some of the matter has to still exist there. You can add matter to it, and you can take matter away, but there still has to be some essence of it for it to be still considered, I don't know, the same form, the same thing, the same matter, the same object.
Right. But you also understand that that acorn was in more way responsible for the oak tree coming into existence than this puff of nitrogen that it happened to use, or this puff of carbon dioxide that it happened to use. If I got rid of this puff of carbon dioxide, that tree would still come to be. If I got rid of that oak, or if I would have got rid of the acorn, that oak tree would have never come to be. So even though you're just doing it in terms of volume, think about what was most critical for that change coming into being.
Most critical.
What was necessary for that to happen? An absolutely necessary condition.
So when we're looking for what exactly is changing, we have to look at the necessary components to make that form come into existence. Are, like, I don't know.
Even when we talk about you, still kind of overthinking it, it's always the acorn that was changing into the oak tree. And that's what we can follow all the way through. Think about all the animals you've consumed in your life. Let's pretend that you are a heavy cow eater. You just exclusively eat cow.
I'd eventually be all cow.
No, you would still always be you. And so some change is going on where that cow is incorporated into you. And it stops being cow flesh, and it starts being partly flesh. There comes a point where that carbon atom stops being carbon dioxide and is incorporated into that acorn.
Okay, so it eventually becomes...
The acorn is what became the oak. And it changed. The same way that partly the baby is what became partly the man, even though the majority of the material that he's composed of came from cows. That's irrelevant because the flesh of the cow was changed into the flesh of partly. So, thinking about the particular thing changing.
Yeah, so, okay. When you would say eventually it changed in the cow flesh changed into the form of partly
Right?
flesh.
You incorporated the cow flesh. The cow flesh did not incorporate you.
Okay.
All right.
I'll just play around with that.
Okay. So an object's actuality dictates its potentiality. A pile of wood, that's wood actually in a pile, is potentially a chair, what it actually could be. In other words, we do not live in a universe where anything could happen. There's only certain things that could happen, and what could happen is dictated by what is actually there. Now, it's important to see how potentiality and actuality are closely tied with matter and form. So, take you through our same example, saying it a different way. Before we said quarks are matter for protons and neutrons. Another way that we can say that is quarks are potentially protons and neutrons. Protons, neutrons, and electrons are matter for or are potentially atoms. Atoms are matter for or are potentially concrete. Concrete is matter for or is potentially a brick or bricks. And bricks are potentially a house, etc. So matter, form, potentiality, actuality. Very closely tied concepts that he's forming to. Think we got so far? Alright. Since a potentiality is a form not currently possessed by an object cannot be potentially what it is actually. If I've got a pile of wood sitting here, it is potentially a chair. That means it currently right now is not actually a chair. You cannot actually be what you potentially are. And you cannot potentially be what you actually are. If I have a pile of wood, I say this is potentially a pile of wood. No, that's what it actually is. That's what he's saying. Since a potentiality is a form not currently possessed by an object cannot be potentially what it actually is. That makes sense? That's important because we're going to get to his argument as to why prime matter can exist. Now, since everything is ultimately composed of matter, you could always reduce it down to some matter. Since everything is ultimately composed of matter, then pure matter or prime matter would be potentially anything. Right? If everything is ultimately composed of matter, prime matter, then prime matter is potentially anything. And if prime matter is potentially anything, What is it actually? It's actually nothing. Because you cannot potentially be what you actually are. So if you're potentially anything, you're actually nothing. So, for Aristotle, prime matter, it's a valid concept. Everything in the universe is backed by prime matter. But he says that it doesn't actually exist. You can never go grab a handful of prime matter and say, here, look. It has to be matter that exists in some form. Looking at it in more modern day, we can have some energy here. When we observe it, it could be at one point an electron. Observe it again, it's at another point a proton. Using even our modern physics, we can't observe it and just see pure matter. It's always matter of a form. Otherwise, it'd be completely unintelligible. What is it? If we can't say it's this, then it has no form. So he's not saying that it's an invalid concept. You can talk about prime matter. It's a valid concept. And everything's ultimately backed by prime matter. But prime matter doesn't actually exist anywhere. If matter ever exists, it exists in a particular form. You can't find formless matter.
That sounds kind of platonic.
Kind of.
So it's like a metaphysical concept instead of a physical concept? Essentially. Like
It is a metaphysical concept, yes.
Isn't it acting on the premise that something cannot potentially be itself?
Right. Since a potentiality is a form not currently possessed by an object cannot be potentially what it is actually.
But he
So yes, that is the basic premise there in terms of what we mean by potentiality and actuality. Okay, so if we have this prime matter, since it's potentially anything, then it's actually nothing. Therefore, there is no such thing as pure matter. Valid concept, but there's no such thing. There isn't some physical thing you can grab that's pure matter. If it's a thing, it has matter and form. And so everything in the universe has both matter and form. Asterisk there. We'll talk about the things that doesn't. There's no pure matter. We'll get to pure form. That'll come later. Okay, so another way that we can talk about change. Change then is a passage from potentiality to actuality. What does it mean for an object to change? It actualizes some of its potential. It went from potentially being that thing to actually being that thing. That's another way that we can define change. A pile of wood went from potentially being a chair to actually being a chair. A change has occurred. Make sense? Examples, when seeds grow into a flower, it starts out potentially a flower, and it changes to actually being a flower. Again, it's just a change in form, not matter. Same underlying matter, we just gave it different form. Okay, I think we did that. So, looking at some chains of potentialities and actualities as example. Start out with grass seed. Grass seed is potentially grass. It's also potentially, I don't know, bird food. But it's potentially grass. I can go plant some of the grass seed. If it takes, we get a grass. Now grass is potentially part of a cow, part of a cow's flesh. Grass is not potentially part of your flesh. You cannot eat grass and digest it and take it into your body. Won't do you any good. So, grass is matter for becoming part of a cow. It is not matter for becoming part of you. You can't eat grass. Won't work. Well, you can, you just won't get anything out of it. Then we have the cow. The cow is potentially beef. We can go cut that up for you. And then that beef is potentially human flesh. So what the thing actually is dictates what it potentially could be. Similarly, an acorn is potentially an oak. We can go chop down the oak. An oak is potentially timber. Timber is potentially a ship.
So
We would not say that an acorn is potentially a ship. You cannot go build a ship out of acorns. Well, maybe you can.
So it's
Not a very good one.
So it's saying that anything can potentially become anything else, but it has to jump between multiple potential form changes.
Right, so that's the point here. We would not say that grass seed, well, I don't know if you can digest grass seed. I guess not. But for sure, grass, we would not say, according to Aristotle, if you say grass is potentially human flesh, you'd say, what a bunch of nonsense. Go try and eat some.
But doesn't that kind of contradict, like the law of equality?
The law of what?
Equality, you have A is equal to B, and B is equal to C, so A is equal to C. Would that not contradict?
Oh, we're not saying is equal to. We're saying it's capable of changing into this. So this is getting into physical things changing. It's not going to be able to be captured in some nice mathematical abstraction like that.
I might want to look at more of the set theory concept more than
That's still going to be way too precise.
Is that like?
Yeah, you will run into all sorts. You try and describe biology using that set theoretical notation, you'll become famous if you can find ways to do it. Have it that reduced. Right now, biology is a very high level science. Meaning we don't have these low level abstractions to directly encode things. We can do that in physics, less so in chemistry, much less so in biology. Although I think it's Whitehead who sure gave it a good try. And then final example, going back to some of how we learn things, sense data is potentially a concept. You can take a bunch of sense data, you can see a bunch of dog, form the concept of a dog. You can also take a bunch of sense data, watch animals die, and come to the concept of mortality. And you might be able to, with that, form the proposition. Propositions we form from concepts, and we might form the proposition that all dogs are mortal. There's a proposition we might form. Propositions, then, are potentially arguments. If you give them the right structure, it forms an argument. If I take the proposition, all dogs are mortal, and I take the proposition, Bingo is a dog, I can combine them into the argument, Bingo is mortal. So, with sense data, we can construct concepts. With concepts, we can construct propositions. With propositions, we can construct arguments. And with a bunch of arguments, you can construct them into an organized field of study, which we call science. What Aristotle means by science here. So, give you a non-so-concrete example. Okay, so this notion gives us our foundation for the view that nature ultimately conforms to laws. Nature ultimately conforms to laws. Laws govern what can and cannot happen in nature based off of what a thing actually is. So what a thing is potentially depends upon what it is actually. Or in other words, what something could possibly be depends upon what it actually is. A more modern way we might say that is future states of a system depend upon the current state of the system. The current state of the system in dictates what future states can occur. And there's some future states that can't occur because that's not potentially what that system could be. What the system actually is dictates its future potentialities. Now, Aristotle is completely opposed to the notion now that anything could happen, so natural laws govern our universe. But Aristotle did not have in mind the completely deterministic laws like what we see in physics. That everything always has to happen. So in physics, if we were in a classical mechanics course, and if I just throw this the exact same way, give it the exact same initial velocity at the exact same time, it will follow the exact same trajectory every time. And it will perfectly follow that path. Aristotle didn't have that notion of natural laws. He thought that natural laws happen always, or for the most part. Because something that confused him, sometimes you plant an acorn and it doesn't turn into an oak. So this is kind of confusing to him. Go plant 1,000 acorns, try and keep all your situations completely identical, and yet only 99 of them become, or 999 become oaks. That confused him. So he didn't think it was completely deterministic, but he is getting at natural laws. Just not quite, I just don't want to jump too much in our thinking by saying that he had like our same notion of Newton's laws in mind when he was saying these things. So if change is matter taking on a new form, or a potentiality being actualized, how does this actually happen? Can potentiality actualize itself? How does an acorn just start turning into an oak? What ultimately causes that to happen? What do we need to know, ultimately, to understand change? So we're going to introduce Aristotle's four causes now. Now, introduce this with an example. Let's pretend that I went and I got some statue here, some beautiful statue. I tell you, I'm a complete expert on this statue. Ask me anything you want, and I can answer that question for that statue. What are some questions you might ask me about that statue? Huh? How heavy is it? So that's one thing. So that's one of the forms it's in, how much it weighs. What else might you ask?
What's it made of?
What's it made of? So what's it made of? That's what Aristotle calls a material cause. What fundamentally that statue is made of, that's its material cause. What else might you ask?
What is it?
What is it? What did I make it into? So I say it's made from marble, and I made it into the form of Plato. So what is it? It's a statue now of Plato. So that's getting at the formal cause. That into which you make the thing. And I made it into a statue of Plato that weighs 87 kilograms or whatever. That's part of what I made it into.
So formal causes.
The form that it ended up with. What else might you ask about it?
Why did you make it?
Why did you make it? Right. So I might say that's the final cause, the reason behind the change, the motive. Why did you do it? And I probably did to immortalize Plato. Thought it would be good for the world to know him. And then finally, there's
Who made it?
who made it. And that's what he calls the efficient cause.
Alright.
So the material cause, if we were thinking about taking some marble and changing it into some statue of Plato, what are our four causes? There's the material cause, that out of which a thing is changed. And that example would be marble. The formal cause, that into which a thing is changed, namely a statue of Plato. The efficient cause, that by which a thing is changed. In that case, it would be the sculptor, his tools, whatever he used to ultimately cause the process to happen. And then finally, the final cause, that for the sake of which a thing is changed. The purpose that we had in mind.
Does every single change have these four causes?
Every single change, according to Aristotle, has these four causes. Furthermore, if you want to understand a change, you have to know these four causes to completely understand the change.
Is there more?
No. So anything you could say goes into that change, we could put into one of these.
Does that imply the existence of a creator?
We will get there. But yes, he's going to ultimately say purpose is behind everything. He's going to be what we call a teleologist. So it's easiest to see first with human action, then to see it with biological changes, then to ultimately see it with just physical changes in general. And so we'll go through each of those stages to see these causes in action and how these changes come to be. So those are his four causes. Ultimately, everything that goes into that change, everything you could understand about that statue coming into being, would ultimately be captured in one of these four categories. Any questions so far? Anything weird about that? Okay. So, to completely understand a change, you must know the material the change started with, the form it ended with, the agent which engendered the transition, the change to occur, and the end or goal of the process, the purpose for which the change occurred. Aristotle says these four always exist.
Why couldn't that change happen that didn't have a purpose?
We will go through all the different types of changes and identify the purpose. We'll start with human changes, biological changes, and then physical changes.
Well, maybe those have a purpose, but why couldn't there exist a change that did not have a purpose?
Aristotle will say all change happens for a purpose. Here's the different changes, here's the different purposes.
Does he give a reason why?
He explains that that's the way that it is, not why it is the way that it is. Although, well, I won't say that, because I'm not sure exactly how he'd answer that piece.
Why is it like how it was changed on this list?
How it was changed is the efficient cause.
Okay.
So you mean like, did the sculptor use a chisel, or did he use I don't know.
Like something else. Yeah.
Yeah. So that goes into the efficient cause. Who's doing it and whatever else they're using to get the change to occur. So that was captured in that.
So is he implying for all change to happen, there has to be some type of catalyst or agent that makes that happen? And
Yes. So ultimately, go to a more concrete example, or a more unintuitive example. I got a boulder sitting on a hill and I notice it falls down. Some agent caused that boulder to fall down.
gravity.
And it could have been, well, you'd say gravity, but following the whole thing out, it could have been lightning struck a tree, the tree fell over, knocked the boulder over, and it rolled down the hill. And so relative to the boulder falling down the hill, the agent that caused that to happen was the tree that hit into it.
Right.
There could be multiple agents, I guess.
It could be a chain of events causing a change.
It
Yes.
could also be like a gust of wind.
Or whatever.
Right.
All at the same time.
Whatever's causing it. But yeah, so there's always, the agent which engendered it isn't necessarily an intelligence.
Yeah.
Could just be a tree falling over. But something caused it to happen.
Well, you can trace that back. How far can you trace that chain of events back?
We're going to trace it all the way back to the unmoved mover.
The what?
The unmoved mover.
That makes sense.
Oh, we'll get there. So, our last definition of change that we'll give up that now captures these things. So what's a change? a transition from one form, its material cause, to another form, its formal cause, by some means, its efficient cause, for some end or goal, its final cause. And that's what a change is, capturing his four causes. So, now the actual question is, do these four causes apply to natural changes, or do they only apply to artificial changes? For Aristotle, they apply to all natural changes as well as artificial changes. Artificial meaning human constructs. Okay. So both an acorn changing into an oak or hitting a tennis ball, he thinks both of those, you could identify these four things. And for the first three, it's pretty easy for us to identify what it is. It's going to be that fourth one that throws us off. So an acorn changing into an oak, what's the material cause? The acorn. What's the formal cause? The form it changes into.
The tree,
The oak.
Yeah.
What's the efficient cause? That's going to be the sunlight, the water, the oxygen, everything that it needed. And then the final cause, what's the purpose? That's weird. That's hard for us to get out of the biological system. Hitting a tennis ball, there's a more straightforward one. What's the material cause? The tennis ball being here. What's the formal cause? The tennis ball being over there. What's the material cause? The racket and the guy hitting the ball. What's the final cause? Well, there it's easy, to score the point. He was trying to get a point. So it's easy for us to see in human change. We'll move on to biological change, help us try and see it there, and then move on to completely inanimate objects. So, how does the final cause come into play when there's no person generating the change? Do things other than humans change for a purpose? Is there a purpose in mind? For Aristotle, yes. Now, it's useful to keep in mind that Aristotle is primarily a biologist. That's his biggest interest. That's where he spent most of his time studying biological things. So, an example. A plant's roots growing around a rock. The rock's there, the plant's roots grow around the rock. Why do the plant's roots grow that way? To get water. They had some purpose in mind. Access to water. And we still describe it that way. A plant bending towards sunlight. Some kid asks you, why are those leaves bending on the plant? You say, to get sunlight. As though that plant had that purpose in mind. It was trying to get access to sunlight.
In mind? I mean,
It's the way you describe it.
doesn't mean it's
That's what it was trying to do.
That it was trying to do something.
It needed
Which
that.
would be there.
Or you cut your finger and you get a scab. Why do we scab?
Our body's
To hold the blood in. Like there was some purpose in mind. Our body says, oh no, we're leaking blood. We've got to stop this. Let's send out what we need to form the scab and stop that from happening.
but it's almost kind of deterministic how that happens. Like, there's no free will in choosing to scab or choosing to grow or sunlight. So how's our purpose behind that?
So we'll get to how the purpose is behind it all. The point is to see the intuition for why thinking purpose must be there. And then finally, another example, your body developing antibodies. People ask, why does your body develop antibodies? Oh, to fight off the virus, as though there was some purpose in mind. They don't say, well, this bumped into this thing, which made it move this way and jiggle that way, such that the antibody started being produced. They say, but why? Right? And so we're always looking for that final cause when we're trying to describe these things. Even if you completely mechanicalistically describe it, the question would always be why. So if you describe perfectly all the mechanics that go towards that leaf bending, someone says, okay, that's all the physical things that are happening that are causing that to happen, but why? Why is it bending that way? And you're going to come back to explaining it in terms of some sort of purpose. Very natural thing to do in the biologies.
And that's what I'm noticing is using only biological events and changes. It seems like he tried to find a universal way of describing all change that happens in the universe, and then he only using.
Nope, we'll get to his physics, I promise.
Okay.
We're going to work down towards it. So, another example, consider all the organs in the human body. We always describe them in terms of their purpose. What does the heart do? It pumps blood. I don't know if they've still figured out what's the purpose of the appendix. How much was that cause for controversy and people arguing this theory or that theory? I don't know if any theory has been worked out yet. But there must have been some purpose for it. There must be a reason that organ is inside the human body. So in the biologies, we're always looking for the why. Why is it there? What's its purpose? There must be some purpose in mind somewhere, right? So it seems that living things are purpose-driven, ultimately trying to achieve their full form or actuality. So far when we look at living things, it seems like they're always trying to do these things that ultimately help them develop towards becoming fully developed. So all the things we see the acorn doing, ultimately it's all for the purpose of becoming that full-formed oak. There's a rock, and the roots grow like this. Why do the roots go like this? To get better access to water. Why does it want better access to water? Ultimately, so it can completely actualize as an oak. And that's what biological things strive to do, to become completely actualized. You want to talk about the animal chasing down, the tiger chasing down the antelope and eating it, or whatever it is. It's always about becoming fully actualized. Living things always have that purpose in mind.
All the living things that didn't have that purpose went extinct.
So on some level, in these biological things, it seems like everything is ultimately acting so that the biological thing can fully actualize itself. And so that's the end purpose in mind, the fully actualized organism. Now organisms, living things, it's easy for us to see how those things develop, and okay, you can kind of see how there's purpose with those. But what about a rock falling down a hill? Where is the purpose there? That doesn't make any sense, right? So, in order to talk about non-living things, non-biological cases, we got to go back and start talking now about Aristotle's physics. So what about non-living things? How to explain change in inanimate objects? To discuss this, we need to first briefly cover Aristotle's physics, and Aristotle's physics largely picks up where Empedocles left off. We remember Empedocles? What's Empedocles? The four elements: fire, water, earth, air. And today, if I were to ask you what are the four elements, chances are you would have already spout out those things to me. So his physics is going to pretty much pick up where Empedocles left off. We're going to have our four elements here, and we're going to have our four fundamental properties. So air, for example, he says is wet and hot. Fire is hot and dry. Earth is dry and cold. Water is wet and cold. And it might also be worth noting, I don't know how much was related, but Aristotle started out the son of a physician, and Empedocles was a famous physician. And so you see him in his system somehow tying it to the blood, the yellow bile, all the things inside the human body. But all we care about is the outer part of this. So we can ignore the inner part from Empedocles. But for his physics, he's going to pick up in that same place. Pick up where Empedocles left off. But he's going to add one more element. So for Aristotle, we have the four, what he calls terrestrial elements, which are going to be earth, water, air, and fire. And then we have one celestial element, which he's going to call ether. And now, each element has its natural resting place. So, at the very center of the universe is where Earth wants to be. And on top of that Earth is the natural resting place of water. And so water wants to be around the Earth. And the natural place of air is around water. And the natural place of fire is around the air. And then outside of that is the natural resting place of ether. And everything naturally moves towards its resting place. If I take a rock and I drop it, let go of it in the air, what happens? It falls until it comes into contact with Earth. And then it sits there. It doesn't want to go down anymore. Earth wants to be at the center with Earth. That's where it wants to be. I take some water and I dump it through the air, what happens? It falls through the air until it gets onto the Earth. And then that's where it wants to be. Furthermore, I light up a fire, I get a fire going here. How far does the fire go? It goes up, because fire wants to be above the air. Or if I go get some air in a bubble and I take it down in the water and let it go, it goes up until it gets with its air, and it wants to be at the air. So the four elements all have their natural resting place. The earth at the center, on top of that the water, on top of that the air, on top of that the fire, and then ether outside of that. Everything has its natural resting place. So each element has its natural resting place, which explains why elements are located where they are in the universe. An object's natural resting place is dictated by the combinations of elements in it. So since he's picking up where Empedocles left off, he thinks ultimately if you pick any substance, it's some ratio of fire, water, earth, and air. And so wood, if we take wood as an example, It's got some air in it, it's got some water in it, it's got some fire in it, or it's got some earth in it, whatever goes into the wood. But the ratio must be such that it's got more air in it than it has like earth in it. Which makes it want to be more above the water than down under the water. And so it floats on the water but falls through the air. And that's because of its ratio of the 4 elements in it. So not only does this give us the resting place of all our different things, but any object composed of these elements, you can see where it naturally wants to rest. Right? And you take some air, you start adding fire to it. What does that air want to do? It wants to rise. The more fire I tuck into that air, the more it wants to go up. So as you change the ratio of these things, you cause them to change their natural resting place. So everything has its natural resting place, and that's determined by its ratio of earth, water, fire, and air. Everything, we'll talk about just the terrestrial ones, and we'll leave off ether for a second and come back and talk about that after. So talked about just the 4 elements so far and things on this earth. Any questions so far?
Did he entertain the idea that there was more to like the elements of Earth, considering different colors and the different densities of different?
So the different densities, he thinks density is purely a consequence of your ratio of these things.
Yeah. So Earth that had more air in it is going to be lighter than other Earth that had less air in it, and so, but he never really dove into the idea that there might be more categories within the category of Earth, for instance.
So these, understand, when you look at your periodic table, what are you looking at? You're looking at the elements. The periodic table from Aristotle's day, for over 2,000 years, had 4 elements on it. Fire, water, earth, air. And so that was not expanded or changed.
So the answer is no.
So it stays stable with those are the 4 elements. And then it's a sudden change to the table we have today of elements. Good? Any other questions? All right. So now, the 4 terrestrial elements naturally move up and down. So ignoring violent motion being motion that violates nature. So inanimate objects, another way to say that, are only capable of motion up and down. If I let go of this, it's just going to fall down. It's not going to fall sideways, it's not going to fall crooked. It's only capable of going down. I have to exert some force on it in order for me to get it to move sideways. But in and of itself, these objects are only capable of moving down or up. If I get some pocket of air underwater and I just let it goes up. Unless, of course, water moving in whatever way pushes it one way or the other. So the 4 terrestrial elements naturally move up and down, and that's it. So even if I take some big heavy rock and I put it on a shelf, the rock really wants to be on the ground, but it's on the shelf. And it can't just move to the side and fall off the shelf on its own, even though it really wants to be on the ground. Strong desire to be on the ground. A lot of potential energy in that rock, another way to say it. So the rock wants to be on the ground, but it can't be on the ground because it's only capable of moving up and down. And so that shelf is frustrating it. Okay. The combination of elements determines the weight. People always translate given saying weight, but what he was talking about was density. I'll use weight just because that's the verbiage that they always use, but he's talking about density. So the combination of elements determines the density of an object. Now, talk about his theory for how these things fall. So, objects on their own can only fall down, or we'll say fall up, even though it sounds funny. And he thought that the speed an object falls is proportional to the difference between its weight and the weight of the medium it's falling through, and inversely proportional to the weight of the medium it's passing through. Okay, that's a mouthful, but I'm going to give you an equation. This is not his equation. This is the equation I'm going to give you to help you understand what he's saying. Let's just close this for a second and give me some space, right? So his equation is roughly going to be the speed an object falls down, v for velocity. Maybe I'll use s for speed. That's probably fair for this group. The speed an object falls down is equal to the weight the object has, or the density an object has, minus the weight of the medium it's falling through over the medium. Now this wasn't his equation, but gives you an idea of what he's talking about. So let's pretend that Earth has a weight of 4, water has a weight of 3, air has a weight of 2, and fire has a weight of 1. Keep it really simple. So now I want to figure out the speed that Earth falls through air. Well, the speed that Earth falls through air is equal to, so the weight of the thing falling is 4, minus what's it falling through? Air, which is 2, divided by air, which is 2. So he says that would give you a speed of 1. Now let's look at Earth falling through water. If we look at Earth falling through water, what's the speed we get? We get 4 minus 3 over 3 would be equal to 1/3. And so the object falls much faster in air than it does through water. If I take a rock and I drop it through the air, it falls faster than if I drop it through water. Why? Because of the difference in weight between Earth and air is bigger than the difference in weight between Earth and water. Similarly, what happens when I drop Earth on Earth? Well, its speed is equal to 4 is the weight of the object falling, minus 4 is the weight of the medium it's moving through, divided by 4 gives us 0 over 4 is equal to 0. It doesn't move. Or, let's look at the speed of dropping air through water. So air is what's falling, minus the medium we're going through is 3 over 3, which gives us a speed of negative 1/3. Or in other words, it falls upwards. There's a negative speed. That's how fast it goes down. It goes that way. So his equation for his thinking for how things move up and down is completely related to density. Now, we didn't take into account the actual structural integrity of something, so a rock can't fall through wood, even though wood is lighter than rock. Because of the structure of the wood, you'd have to break through it, but that would be more like a rock falling through sawdust, if you completely broke it up into a bunch of pieces. Then the rock could fall through sawdust, because the rock's denser than sawdust. Make sense?
Yeah.
So now he has a natural question. What about a vacuum? What happens if we drop Earth through a vacuum? So we want the speed when we take something like Earth that has a weight of 4. Now, how much does a vacuum weigh? If it's completely empty space, nothing there, what's the weight of that? Nothing. So 4 minus 0 divided by 0 gives us what? Doesn't really work.
Yeah.
Let's say that you're dropping it through a vacuum where you've pumped out tons and tons of air so that the density is super low of the amount of air in there. So we got air where it's almost a complete vacuum. You with me? And we're dropping Earth through it. So the speed will be 4 minus, and we'll pretend that that is 0.0000001. You know, something ridiculously small. We've almost got a perfect vacuum. We pump all the air through there. And then that's divided by 0.0000001. What's that going to come out to? A really big number. It's going to come out to approximately for whatever it's going to come out to. Really big number. So as we get closer and closer to a vacuum, how fast do objects fall through that vacuum? Faster and faster and faster. So imagine now we got a perfect vacuum. There's nothing impeding the object. How fast does it fall? Instantly. Right. So if you have a perfect vacuum, an object instantly falls from point A to point B. And if an object instantly falls from point A to point B, at the same instant, it is at point A and point B. Impossible. Well, so he thought there was no such thing as vacuums. This formula, I just gave you this for intuition. That was completely my coining to give you a sense for what Aristotle was talking about. So this is how he makes sense of how objects fall or move up on their own, when you look at motion in nature just like that. And so, to his mind, it is completely impossible for there to be a perfect vacuum. No such thing can exist. Now, who's he arguing against when he's arguing that there's no such thing as a perfect vacuum? Who argued for the vacuum? They also called it the void. The atomists. So this is one of the ways he's dealing with the atomists. Atomists say all that exists are atoms in the void. Aristotle thinks that that's nonsense. You can't have a perfect void. And there's his argument why. So, gives you a sense for flowing objects and why. Make sure I covered all this. We kind of talked about all that. What happens if you get rid of, okay. I think we covered all that. Any questions about falling objects? All right. So, a terrestrial object, left to its own devices, will only move up and down until it reaches a natural resting place, where it naturally wants to be. Remember, he doesn't have this theory of gravity. You need to try to picture, you've never been taught anything, throw yourself back in time. How do you explain why this rock keeps moving downwards? I can never train the stupid thing to just stay there. Every time I let go, it just moves down. Try it again, it just moves down. And it won't just stay put. It never moves sideways when I don't want to. Why does it keep moving down? It really wants to go down. Until it gets to its earth, and then it's so content. Right? You budge it a little bit to the side, it just sits there. I put it up on a shelf, I budge a little bit to the side, it just goes down. Or you try keeping a bubble of air underwater. It really wants to be up there. So these things really want to be at their certain levels. And so they desire very much to be there. And if you would get out of their way, that's where they would go. So that's their purpose that they have in mind. They want to be at their natural resting place. That's where they're trying to get. Now, for there to be any side-to-side motion, there must be an external force acting on the object. So the object can't naturally move off the shelf until you push the rock. Then the rock can fall off the shelf. Or you might push a rock, or a tree might fall against a rock, causing it to roll down a hill. It can't just roll down the hill on its own if it needs some sideward motion to do that. The side-to-side motion only exists while an external force is being applied. So again, Aristotle, he's trying to come up with laws of physics. Think about this for a second, back to our normal experiences. Here I've got a box of items. When I push it, it moves. It's amazing. The second I stop pushing the box, what happens? It just sits there. I push it, I stop. It stops. I push it, I stop. It stops. It seems like if you want an object to keep moving, you have to keep pushing it. Right? So for Aristotle, if he were to give his law for motion, he would say force is equal to velocity times mass. Now, jumping ahead, obviously Newton came along and said force is equal to acceleration times mass, not velocity times mass. So Aristotle's wrong here. Don't let it confuse you. Aristotle thought that in order for an object to remain in motion, there must be a force always acting on the object. One of Newton's laws is an object in motion will remain in motion unless acted upon by some net force. So Aristotle didn't have the thought experiment of if I take this chalk and I throw it in outer space, what's going to happen? It's just going to keep moving that way forever, and I don't have to keep pushing it.
He didn't have an idea of vacuum.
Or
Right.
take into account like friction, air resistance.
Right. So all he's thinking about is our day-to-day objects, of your day-to-day movements. And in order to maintain that force, or that motion, it seems like you have to continually keep pushing on something. So he thinks force produces a velocity, not an acceleration. So for side-to-side motion, the side-to-side motion only exists while an external force is being applied. And the side-to-side velocity is proportional to the force on it. So in other words, if you and I are pushing boxes that each weigh, yours weighs 20 pounds, mine weighs 10 pounds. And if we're pushing alongside, we're going at the same speed, Aristotle says, you must be pushing twice as hard as me. Because your box weighs twice as much and we're both going along at the same speed. Or, if we have boxes that both weigh the exact same, but you're walking at 5 miles an hour and I'm going at 10 miles per hour, I must be pushing the box twice as hard as you. That's what Aristotle thought. So, that's what we mean here. And the side-to-side velocity is just like how fast you're moving. Hopefully that's an okay term. And the side-to-side velocity is proportional to the force on it. If you and I push a box at the same speed and my box is twice as heavy as your box, I must push the box twice as hard. In other words, he thought force is equal to velocity times mass. That's expressing his equation, which of course he never did. Okay, now one of the motions that confused Aristotle, because he was used to pushing boxes around, but he was also used to throwing a ball. Take a ball, throw it, it keeps moving that way. It has its natural motion, which is the ball instantly starts falling to the ground because it's composed of 4 elements, and so that makes it want to go to the ground. But after I let go of the ball keeps moving that way. How do we explain that?
Yeah, I'll say it right.
The air keep pushing the ball.
That's what he thought. So he thought as I throw the ball, I'm creating a vortex behind the ball of empty air, and the air collapses in. And as the air collapses in, it hits the ball, continuing to push on it as the ball moves. That's what he thought was happening.
That would slow the ball down when you push it forward. That's what drag is.
Well, so the picture he has in mind is as it moves forward, and there's empty space right there, then the air is falling into that space, hitting the ball in the back. That's the idea he has in mind. Somehow creating a vortex that as it's filling in is propelling it forward.
Wouldn't it propel forward? Couldn't you have?
None of this is valid physics. This is wrong. This is not a good equation. This is not how a ball moves. It's wrong. This is how he's trying to explain it.
It's a really bad way of explaining
They
it.
had the technology for instruments anyway to be able to create a vacuum.
No.
Okay, so he's never experimented with the concept.
The notion of even taking the time to experiment with all these things isn't a notion that comes up clear until we get to the Enlightenment. This notion of experimentation. Instead, what they do is you have your common experience and you just inductively reason on that to your premises. For example, he thinks heavier objects fall faster than lighter objects. Now that's true to some extent. A bowling ball falls faster than a feather. However, a bowling ball and a little pebble, it turns out, fall at the same rate, pretty much. So they didn't take the time to make these fine distinctions and see how and when exactly their theories hold.
I think
And secondly, understand Aristotle is not a physicist. He is spending the majority of his time in biology. He is developing all these fields. He is not going and carefully measuring all these things. So he lays it out. He says, here's the way it appears to work to me, and here's the obvious problems that I still have that I don't have good explanations for. And he moves on his way. He didn't dwell on these things trying to, well, I don't know what he did. I don't think he spent much time dwelling on these things as much as he did on biological things. That's where his interest really lied.
Yeah, it seems like, honestly, he's doing exactly the same thing we're doing today. All the time we come up with new discoveries that alter our laws and rules that we've created.
So the way that he's going about this is scientific. He's laid down the rules for science that we now use today.
Yeah.
It's just he's inductively reasoning on common experience rather than setting up actual experiments. That's like one of the 2 tweaks that you make to Aristotle's theory to get our more restricted notion that we use today. And it turns out it's way more effective. So, yes. But any other questions on that? Not how is this true, because it's not, but does it make sense to you what he's arguing for? Alright, so now that we've done with local physics, let's talk about celestial objects. So what about celestial objects? Now, for Aristotle, again, put yourself back in his shoes. He knows that it's a matter of record that the heavenly objects, for him, heavenly objects means everything starting with the moon and going beyond. He knew it was a matter of record that they've always been traveling in circles. This is stuff that people have been documenting for hundreds of years. They always travel in circles. Now for him, natural objects only move up and down. These ones are always moving in perfect circular paths, rather than this up and down motion. So that's where he gets that they must be composed of some 5th element, some different non-terrestrial element, which he calls ether. So therefore they must be composed of a new element, ether, one whose natural motion isn't up and down, but is rather circular. Make sense?
He's referring to like the dots in the sky, like Mars and stuff, that you'll just see these weird objects moving around every night.
Well, they understood planets and they understood the path that planets took. They had a lot of understanding about how the heavenly bodies moved, and it's very well documented.
They have primitive telescopes.
I know.
Just gotta look that up.
But even then, in terms of documented planets and where they were, they've gotten up to Saturn.
Really?
Yes.
Okay, well, it looks kind of like a star. I imagine that they.
But they were meticulously charting these things.
Got it.
And so when it comes to just having pure data for how things move, nothing is better documented than the movement of the heavens.
Through history.
That is why early physicists are all excellent astronomers. When you talk about Copernicus, Kepler, Galileo, they're all studying astronomy inside and out because that's what you have all this history of people meticulously documenting and coming up with theories for it. I mean, if you remember back when we were talking about the curriculum at Plato's Academy, he talked about we need arithmetic, geometry, and then astronomy and music. What did he mean by astronomy? He did not mean it the way we mean it in our modern sense. He meant the study of motion you can see with your eyes. And the heavenly bodies are the most consistent medium of objects that we can look at how they move with our eyes. It was Galileo who realized actually we can get consistent motion by falling objects here. Prior to Galileo, everyone thought that's very variable in how these things fall and move. But the heavens, they have been very consistent. So if we want to talk about motion, this is a great field to study, to understand how objects move. So there's where they do a fantastic job, have a lot to go back on. For a bunch of these other things, Aristotle's the first one coming up with theories for them.
So, he thinks they're, like the moon is made up of ether?
Yes,
So how does he, so he thinks the sun and the moon are made of the same thing?
they're made, the stars are for sure pure ether.
Okay.
As we go further out, it's more dominantly ether. As we come further in, it's more dominantly our four elements.
But they still move in perfect circular motion.
Kind of. He knew, for example, Mercury didn't.
Okay. What is the black stuff in the sky then? What's the actual night? Like, yeah, you can see the stars, but what's the void?
Oh, you got a word for it. It was somewhere in there. What's it called? It's above ether.
Oh, so for him, it's just filled with ether, less dense.
So, less than, okay, less than.
All the way
Yep.
to the top.
There's more density and less density, but there's no such thing as just this empty vacuum. Turns all the way down. Yeah. Okay. So, let's see. Right, so these things, they must be composed of some new element, ether, one whose natural motion isn't up and down, but is rather circular. So, he would say there's no way that the moon could be predominantly composed of the same stuff as the Earth. Otherwise, it'd be right here. It would have fallen. So it must have a predominance of ether. Now, one of the things, understanding these spheres also, because we're going to talk about the spheres. Well, we'll get to it when we get the picture because it can be a little bit confusing. But Aristotle also argued, if you remember all the way back to the Pythagoreans, they talked about the harmony of the spheres. So, going all the way back to the Pythagoreans, they thought that all these spheres were moving around, carrying the planets and carrying the stars, and that they produced a music, which they called the harmony of the spheres. And the reason that you can't hear it is because you've always heard it. And so you've never had an opportunity to not hear it. And so what you think is no sound at all is really the harmony of the spheres. You've never had the contrast. Aristotle argues against that. So, Aristotle says, first off, even if we can't hear it because we've never known the contrast, sound still has a visible effect. It has physical side effects of there being a sound. You might think of an opera singer causing a glass to shake. If I get strong enough sound, you can feel the sound. So if there's these big heavenly orbs twisting around, creating these massive sounds, it should create these physical consequences that we can see. We should somehow see some vibrations going on somehow, some way. If these sounds are actually out there, they should be physically detectable some way. And yet we detect nothing. So he says Pythagoreans are wrong. He says, and even if you're right, it doesn't matter. Typical Aristotle. To give you his exact verbiage, what's the difference between a harmony no one can hear and that has no physical effect on the world, and no harmony at all? So you're wrong, and even if you're right, it's completely pointless. So there's his argument against the harmony of the spheres. But so he did think that the Earth was at the center of the universe. that accords with his theory, right? That's where Earth wants to be, is at the center of the universe. And he thought as you went out, you had first the moon, then Mercury, then Venus, then the sun, then Mars, then Jupiter, then Saturn, then the stars.
What was his reasoning for that order?
So the reasoning for that order would be how they detected these things moving past each other through all their data. And so it's interesting that they got Mercury, Venus, rather than Venus, Mercury. They could have gone either way there.
And Mars past the sun.
So no, that one's easy. So if you think about our actual picture, so here's the sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, stars. So here's Earth. Now from their perspective, Mars, you can see move behind the sun.
Oh, that makes sense.
So Mars is further out, but how they ended up getting these orders, it's kind of somewhat lucky. And they must have saw something past something.
Well, it seems like all of them would have passed the sun.
So all of them could have passed the sun by going behind the sun, but Mercury and Venus, you can't ever, well, I don't know how they would have actually located these things in the night sky. I think they mostly would have had to have seen how stars pass by each other. But nonetheless, whatever the thinking was, it's kind of crazy how they got the order.
Yeah.
Because the order that they do have, if we talk about in terms of proximity to the Earth, it kind of works. If you talk about average distance to the Earth, they got it right on. That's the order it goes in. But they could have had all sorts of clever trigonometric arguments for how they put these things together. I have no idea. I tell you, the one place that these guys shine, it's astronomy. They've been looking at the night sky for a long time. Anyways, so yep, not positive how exactly they got that order, but that's the order that they had on it. So, Aristotle viewed the Earth at the center of the universe. What does this mean? This means if I take the whole Earth and I shift it a foot in this direction, it would fall back down a foot. And then sit there. It's in the perfect center of the universe. Now, he suspected that the further away from the Earth an object is, the more perfectly spherical its path should be. And we've already briefly talked about that because it should be more ether, less the terrestrial objects. And so it should have a more perfectly circular path. And so he was confused. This is one of the things he points out in his theory. He says, here's my theory. According to my theory, since Mars is further away from us than the moon or the sun, Mars should go in a more circular path. And yet, the simple fact of the matter is, relative to the Earth, the moon and the sun go in far more circular paths than Mars does. So he says, here's what my theory says. Here's what the facts are. I don't know how to fix this. Now you might say, why didn't he think to just put the sun at the center of it all and have everything go around the sun? And then that fixes your circle problem. Which he considered.
Where is the Earth going if it's not centered? I guess.
Well, he could say, so my physics is wrong, but let's see if that fits the data better. So he had a problem with putting the sun at the solar system and drawing it out the way that it actually is. And here's his argument against that. It's called the parallax effect. So if you hold up your finger right in front of my face, and you close one eye and then close the other eye, you'll notice in one moment I look like I'm on the right side of your finger, and the next I look like I'm on the left. So here's what he's thinking. Here's the sun, here's the Earth, going around the sun. Now if we look at some star, when we're on this side, pick a star up here, this star, circle the star we're talking about in the yellow star. So here's the star we're talking about. When the Earth is over here, it should look like it's on the left side of this star. And when the Earth is over here, it should look like it's on the right side of this star. And yet we don't see this effect. And so one of two things. Either the sun isn't at the center and the Earth actually is at the center, and we've got to figure out why Mercury's orbit is weird. Or those stars in the night sky are so stupid far away, it makes no sense to even talk about the distance. In other words, if this was the distance from the Earth to Mars, the distance to the closest star, I can't draw it. It's so stupid far away. So he knew it had to be one of these two things for there to be the parallax effect so small that you can't really see it. Now it turns out there is a parallax effect, and it's so small that there's no chance that you're going to see it with your naked eye. But so he was trying to weigh what was more absurd. That the Moon, Earth, Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn are all really close bunched up together, and then the stars are so much stupid further away that it makes no sense to talk about that distance. Or that the Earth is at the center. He thought the Earth being at the center was less absurd with the data. So that's why he argued the Earth being at the center of the solar system, or at the center of the universe, not the Sun.
I didn't even know that they were considering the possibility of the sun the center back then.
Yes.
That's
Yeah.
cool.
So one of the nice guys, they did a great job documenting. And so, again, he had tons of data to go back on and look at this. And the nice guy keeps looking the same no matter when you look at it. We don't get that parallax effect. Now, one of the other things Aristotle argued for, this time being right rather than wrong, is that, well, give you how they ended up fixing this Mars problem. So they thought that for some reason the planets travel in circles while they travel in circles. And that's how this problem was tweaked to fix Aristotle's glitch. And so if you look at the Ptolemaic model of the solar system, which is the model that stands all the way until Copernicus, they think when it comes to the planets, they're traveling in circles while going in a circle. And so that both those things are happening. And they came out with mathematical descriptions that perfectly captured the data that they saw by having it go in circles as it's going in circles.
Wow.
Now they get a bit nuts with this once we get closer to Copernicus. So Copernicus comes along, and he puts the sun at the center, which helps fix the data at the time. But they still have the problem that even when you put the sun at the center of the solar system, things aren't quite going in perfect circles around the sun. And so they were forced to reintroduce, oh, they must be going in circles as they're going in circles around the sun. And that ended up not working. So they said, it must be going in circles as it's going in circles as it's going in circles around the sun. And they started doing circles and circles and circles and circles, coming up with these super complex mathematical descriptions for how exactly these planets are moving. Until Kepler came along and says, guys, it's just an ellipse. It's not a circle. And that was finally the transition away from these heavenly bodies just wanting to move in circles. Took a long time to make that transition. Keep in mind, that's still before Newton describing gravity. Newton's description of gravity was huge. It's hard for us to even come close to appreciate. It's so ingrained into everything we think. It's just seeped into our culture.
Who was it that discovered the ellipse concept?
Kepler.
Kepler?
Kepler. He discovered, he was just pure Pythagorean. There has to be this beautiful description for how this is working. It can't be circles and circles and circles and circles. And so, just by brute force working the problem, came up with ellipse fits the data. Just a dedicated man to a math problem. He's nuts. Because he has two other laws that he ended up coming across just by brute force working it. Just his blind belief, there's got to be some beautiful description. This can't be right. And just working away at it. Not deducing from laws, just flat out working, it's got to fit some nice math. Has to be. It's nuts. Now, Aristotle also gave arguments for the Earth being a sphere. So he thought the Earth was completely spherical. One of his reasons, the obvious one, is it perfectly fits his model. If all the Earth naturally wants to fall to the very center, it's all going to coalesce in a sphere around the center of the universe. Okay, that's not a very compelling one. The second one is they knew that during eclipses, when the Earth casts its shadow on the sun, or on the moon, sorry, that it casts a circular shadow. And so, it must be a sphere casting the shadow. Third reason that he argued that the Earth must be spherical is just from an observation being at sea. Understand that Greece, right there on the peninsula, he spent a lot of time next to the sea, and he knows that you can see the sails of a ship before you can see its hull. And so he thought that the reason that that's happening is because the Earth is curved, and so as the ship is coming by, to give an exaggerated picture, you're standing over here, drew you too tall, then your vision can't quite see the hull, but it can see the sails. So
Aristotle was the first documented person to come up with that.
there were arguments for it. Here were his arguments for it. And then finally, his most impressive argument for it, I think, is he noticed that on the Earth, because again, what these guys have well documented is the skies. So when you look at the stars in the night sky on the Earth, you notice when I'm over here in Greece and I look at the horizon, we'll just draw them as a dot. When I'm over here in Greece and I look at the horizon, this is the first star I see in the night sky. Yet when I'm over here in Egypt and I look at the horizon, I can now see stars that I couldn't see before. And so depending on where you were on the Earth, you had access to stars in the horizon and other stars went out of your other horizon based off of where you were. And I think it's his pupil, the person that he hands his school over to, Theophrastus, was the first one to actually come up with a measurement for the circumference of the Earth, which he approximated using this style of thinking at 25,000 miles. It's not bad. It's a little over 1,000 miles off, so pretty good. So those were his arguments for the Earth must be a sphere. And then mention the spheres. Okay, so the last thing I wanted to mention with him is for Aristotle and for all these guys, when they're talking about these planets, when they're talking about the spheres, they thought that there was an actual sphere around the Earth that the moon was encased in. And it's a whole sphere, and the moon is encased in that sphere. Similarly with Mercury, similarly with Venus, similarly with the sun, and then finally with the stars. There's a big sphere, and all the stars are encoded in those spheres, and those spheres all rotate. And that's the motion that they see.
So it wasn't.
It's not these objects just hovering in space, unsupported.
Okay, let me get straight. Was the Earth static and everything else was moving? Or was it possible that they were both moving, the Earth and, were they considering that possibility, that the Earth and the stars and the planets were moving?
The Earth does not spin.
Okay, that's what it was.
Ether spins. And so when we're talking about the spheres, the rotating spheres, because this always confused me reading old philosophy. It took me forever to realize what on earth they were talking about. Because I always thought the spheres they were talking about was like the sun and the planets as being spheres. No, they think that they're actually embedded in spheres. And the one that makes the most sense is the night sky. If you were to just go lay out and stare at the night sky for a long time, you just see it rotating around you. Now, it looks like just a big sphere rotating. It's what it looks like.
They have an estimate on how long, how far away that was then?
No, they had no estimate on how far away the stars were, but they had no idea how massive the observable universe was.
Yeah.
They thought it was finite in size.
What would they think would happen if you built a huge tower and just went to the stars?
If you built a really huge tower, you'd come into contact with the first sphere, encasing the moon.
Could you get past that?
Don't know.
How could you see Mercury if you couldn't get past the moon?
It's a transparent sphere.
Okay, now I'm more confused.
I don't know if the sphere of the stars is transparent
So there's a
or if
ton
it's
of
black.
spheres.
There's a ton of spheres, and they're all transparent spheres.
And they're invisible?
Transparent.
They're transparent?
Like
And they're-
glass.
And they're like controlling all of these other objects?
So there's a bunch of spheres just rotating.
Okay.
One sphere contains a single object, namely the moon. Next one out contains a single object, namely Mercury, Venus,
Wait,
etc.
But when we look at the moon in the night sky, over the course of a month, we can tell that the moon's, what we see on the moon slightly changes because the moon is a sphere. So if they were looking at
The moon is a sphere encased in a sphere. It's not the moon is moving in an orbit of its own accord, just hanging out there. The thing causing it to orbit is the transparent sphere it's implanted into.
Are these spheres rotating inside of the spheres that they're moving in?
Yes, yes. Spheres rotating inside spheres, rotating inside spheres.
Why was it not more like a hula hoop or something? Why did
It's-
it have to be a sphere?
So dumb.
I don't know why they chose a sphere. If it was just a hula hoop, I guess the idea would be what's supporting it. Because if it's a sphere all falling towards the center,
Right, that makes sense.
it's like theoretically, we could build a sphere all the way around the Earth. And it would be supported because all of it is being pulled by the center of the Earth inwards. Like a Dyson sphere around a star, if you're familiar with sci-fi.
Like an arch of a bridge.
So it's the same concept.
Yeah, yeah.
So it's got to be spheres supporting these objects.
Weird. But they also thought that ether rose upwards.
Ether,
Wasn't subject to the four elements.
ether's not like the four elements. So ether naturally wants to move in circles.
So
I
why-
don't know to what extent the elements are mixed in.
So if
Because
they-
I think Aristotle would think that a lot of the glowing somehow has to do with
fire.
fire.
So if they didn't think that ether was like the four elements, why did they have to justify it being supported?
Because it still has terrestrial elements. So they're not opposed to, the moon has Earth on it. So that's okay. But whatever the ultimate sphere is mostly ether, causing it to rotate as it did.
Why couldn't
In fact, they knew that the moon was reflecting the sun's light. And so they would probably think, the moon's got a lot of earth and the sun's got a lot of fire.
Yeah, it's just different densities and mixtures of the elements is what causes them to be farther.
Right. That's so weird though.
It is weird. But it was the standard way that this was viewed for so long, is all these things just encased in spheres rotating. Took a long time to break that thinking. But that was the first way it was ever thought of.
So why don't we hear them? Like Pythagoreans were talking about, the music of spheres. It seems like that would generate some kind of noise.
Right? It seems like it would generate a lot of sound. Aristotle says it's an observable fact that we don't hear.
Right. Why?
He didn't have an explanation for what necessarily produces all the sounds that we hear. He just thinks if they were producing sounds, then we should somehow be able to detect it. Alright, so there's how we viewed the heavenly bodies. So it appears that in every change, there is a final cause, a purpose for the sake of which the change occurs. Everything in the universe seems to be striving towards some final end. Even with these inanimate things like Earth, what does it ultimately want to do? It wants to be at the center. It wants to be with Earth. That's its desire. That's what it wants to do. And then he goes on to say, besides, how would the atomists, who claim there is no purpose and that everything that occurs is a chance event, account for the uniformity in the universe? So he thinks because of the uniformity in everything, there must be some ultimate purpose everything is targeted at. Otherwise, you have pure chaos, just random things always occurring. If it was always just chance, how come an acorn never becomes a maple? How come it only ever becomes an oak? Weird. There must be some order to it, some natural law governing over that thing, some purpose guiding it in its transition. In all natural change, everything is striving to get where it's ultimately going. And so in this sense, the formal cause and the final cause are the same thing. So for natural changes, Aristotle ultimately thinks that the formal cause and the final cause coincide with each other. They're one and the same thing. The acorn became an oak to become an oak. That's the whole purpose of the acorn, is to actualize itself into an oak. And everything it's doing is ultimately to become an oak. So but all the changes that happen to that acorn, all those changes are ultimately changing it into an oak. And why? For the sake of being an oak. Why does all the developments that happen in you? To make you a man. Why? For the sake of being a man. That's why. That was its sake. Why does that rock fall to the ground? Ultimately, to get to the ground. That's ultimately where it's going. That's its final purpose, to get to its natural resting place. So the formal cause and the final cause are one and the same thing. An acorn becomes an oak to become an oak. The rock fell to the ground to get to the ground. That's where it naturally wanted to be. And so that is how he describes change. So Aristotle is a universal teleologist. He believes that there is ultimately purpose behind all action and all change. Aristotle does not believe in perfect determinism and thinks that there are chance factors that could prevent an object from becoming fully actualized. Sometimes an acorn doesn't become an oak. So it doesn't always happen, it's not a guaranteed thing, but that thing always strives to fully actualize itself. That's the purpose that it always has in mind.
But one object can have multiple possibilities. So which one is the one that it's striving for, or that it wants to be?
To the extent that it's one thing, it has one end, and to the extent that it's another thing, it has another end. To the extent that there's earth in this thing, it wants to be to the ground. To the extent that there's fire in this thing, it wants to be up.
But like an acorn wants to be an oak tree,
Mm-hmm.
to be an oak tree.
Mhm.
But that it would be just as valid to say the acorn wants to be decomposed organic matter because it wants to be decomposed.
No, he would say that is not the case. How do we determine what it wants to be, what it naturally becomes, what's natural for it to do, is what happens always or for the most part. So remember, he didn't think that these were perfectly deterministic things. He thought that they were always or for the most part.
What about objects that have a 50% chance of doing two things? So they can either do this or they can either do this. Which one is what it wants to be?
Or get eaten by an animal.
Need an example of that. He didn't find those types of things in nature.
Well, I mean,
Man-made things are for man-made purposes. Those are different. Their formal and final cause do not coincide. When it comes to natural change, then the formal and final cause always coincide. That's what he's saying.
what makes man different than nature?
One of the things is we have artificial creations.
That's a rabbit.
We are not bound by just, well, we'll get, when we get into his psychology, his hierarchy of existence. So we'll do his psychology next time. We'll finish up getting to his unmoved mover, how movement ultimately comes in here in his view of the universe, his hierarchy of existing things, and then we'll start his psychology next time. So I wanted to end this with ending with change. Understanding how he views change. So in every change, there's the material, formal, final, and efficient cause.
Didn't he have like 3 definitions of change?
Uh,
That we've got over.
So it's ways that you could have described it, capturing the exact same thing. The last one I think is the best. I just wanted to work up to that. So in every change, he would identify the 4 causes. And so that last one that talks about the 4 causes is his most complete notion as to what constitutes change. When I said, here's a definition he would give, I meant, that was my own verbiage. I wasn't actually pulling that out of Aristotle. Any other questions about change? Go ahead.
No, I hope we're gonna finish this. That last part is very interesting. Never mind.
Yeah, we'll pick up here next time.
Okay.
I just wanted to finish natural change.
Okay, so you're saying we haven't gone over this whole section yet?
So far we've only finished change occurs, which is a big part of it. Last thing we got to talk about is how motion ultimately gets started in this universe. We get to his unmoved mover, what we call Aristotle's God, and then we'll get to his psychology.
I was just wondering if you finished this slide.
No, we'll restart on the slide.
Then I'll leave it.
Probably restart by reminding you of the spheres. Probably start on this one next time.
Okay. I'll leave it for next time.
Okay, any other questions? All right, well, there's the majority of his metaphysics.